Hi everybody. In this video, we're going to be talking about how to simplify square root expressions, or how to simplify radical expressions. Before we start simplifying, we do have to agree on what the definition of a radical is. For this class, we will be referring to a radical as just another name for a square root. So for example, if I gave you this symbol, you could say radical 4, or you could say the square root of 4. Either of those would work. So we're talking about taking square roots. We're looking for what number times itself would give us the value inside of our radical, which we call the radicand. So in this case, what number times itself gives us 4? That would be 2. What number times itself would give us 81? That would be 9. And we know that's the case because 9 times 9 is 81. Now notice that I am taking only the positive values. That's because we're not doing this thing. If I had x squared equals 4 and then I took the square root of both sides, in that case, x would be plus or minus 2 because there are two values that satisfy this equation. Positive 2 squared is 4 and negative 2 squared. The issue is with this, they have already given us the square root. So there is an invisible plus sign out front, so we know that these values will be positive. And we can keep going, and you could use a calculator to help us. The square root of 256 is 16. The square root of 121 is 11. The square root of 324 is 18. And the square root of 1 is 1. Now, when we have this radical of a fraction, you could just take the square root of the numerator and the denominator. So the square root of 64 is 8, the square root of 81 is 9. We do the same thing over here. We have the square root of 1 is 1 over the square root of 16, which is 4. So our answer is 1/4. And if we repeat that, we would have the square root of 9 over the square root of 100, which is 3/10. And this one would be 5/7. Now you notice that I did that pretty quickly. That is because I have memorized my smaller perfect squares, like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. You need to know these. If you don't have them memorized, then at the top of your papers, you should be writing down those values because we're going to use them to simplify our expressions. So let's talk about simplifying. The issue with the square root of 24 is we could approximate it as a decimal, but we want exact values. So that means no decimal. We want to leave it as an expression. Now, the square root of 24 has factors. Remember, factors are any two numbers that multiply to give us our value. So for example, if I look at 24, 24 is equal to 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. These are all of our factors. So now that I know my factors, what I'm going to look for is the largest perfect square that is a factor of our number. So I'm looking only for these values to be a factor. Now, if we look at this, the only perfect square that I listed is 4. So that is going to be the biggest perfect square. I guess 1 is as well, but 1 is not going to help us make it smaller. So in this case, I can write 24 as the square root of 4 times 6. And one of our rules of radicals is that you can split up a radical into 2 or more multiplicative values. So I can take the square root of 4 and leave the 6 by itself, because 6 is not a perfect square. So if I take the square root of 4, I get 2, because I know 2 times 2 would give me 4. And because I took the square root, there is no more radical. The process of changing it from a 4 to a 2 is what got rid of the radical. Just like if I did 2 plus 2 equals 4, I would not leave the plus sign there, right? It's not just 4 plus. I use the plus sign to come up with a new number. The same way the square root of 4 is 2. We do not use that radical anymore because we already used it to get the 2 value. And then the square root of 6 is not a perfect square, so I'm just going to leave it the way it is. And that is a simplified radical. The nice thing about this is that we can often get this number in the radical very, very small, which helps us find things like terms. So let's try this again. Let's look at 48. So what numbers are factors of 48? And if you notice, they do tell us to look for the greatest one. So my strategy is start at the bigger numbers and work backwards, rather than starting at the lower numbers and working up. So 36 is not a factor of 48. You cannot multiply 36 by a whole number to give you 48. Same with 25, that one does not work. But 16 does work because 48 is 16 times 3. And I could use my calculator to help me figure out by just putting into my calculator 48 divided by 16 and seeing if that gives me an actual number. So in this case, once again, I can split this up into 2 different radicals. And I can take the square root of 16, the square root of 16 is 4, and then I leave the radical 3 the way it is. And our answer is 4 root 3, or 4 radical 3. Now what if you did not take my advice and you picked 4 because you knew that 4 was a factor of 48? Let's see what would happen there. So if I do 48, I could do 4 times 12. And then I split it up and I get square root of 4 times the square root of 12, which is 2 square root of 12. But this isn't good because now I have 2 different answers. Well, what happened here is that you are not done yet. You have to repeat the process. We're going to leave the 2 where it is, but now we're going to write 12 with its own perfect square factor, in this case 4 times 3. So then I have the 2 that's still out front, and then the square root of 4 times the square root of 3, which is 2 root 3, and we're going to multiply by that 2 that we left there. And if we simplify that, I can multiply those coefficients together, and we get 4 root 3, which was our answer. So it's okay if you are having difficulty finding the greatest perfect square. The issue is you do have to check, once you get to your answer, are there any more perfect square factors that go into my value? Any numbers that you get outside of your radical, you multiply them together. So let's try 72. This is where I might use my calculator, and I could ask myself, 72 divided by 64? That doesn't work. 72 divided by 49. That doesn't work. 72 divided by 36, though, that gives me 2. So I know my factors can be 36 and 2. Now we take the square root of 36, square root of 2, and we're left with 6, square root of 2. One more example with whole numbers. The square root of 90, you might recognize that this is 9 times 10. So we would get the square root of 9 times the square root of 10, which is 3 root 10. Now I do ask myself, are there any other perfect squares that multiply to give me 10? But if I look at my list, the only answer is 1, and that doesn't help us simplify things any further. Now we can look at an example where we have a coefficient. Remember, the coefficient is being multiplied by our radical symbol. So what we're going to do here is we're going to leave the 2 where it is and then break down the 54. Well, what are some factors of 54? 54 divided by 49 won't work. 54 divided by 36 wouldn't work. 54 divided by 25 doesn't work. 54 divided by 16 doesn't work. So 54 divided by 9, though, that gives me 6. So I know my factors are 9 and 6. So I have 2 root 9 root 6. You notice the 2 is staying as a coefficient the entire time. So now I have 2 times 3 times the square root of 6, which gives me 6 square root of 6. I do want to emphasize that you should be writing that 2 down on every line. A common mistake that students make is forgetting that coefficient, and they would write the answer as 3 root 6, but forget that there was already a 2. We can try one more example. Now, I want to show you one last trick. We already simplified the square root of 48. We know that square root of 48 is 4 root 3. So all I'm going to do is bring down my 2, and we get 8 square root of 3. The more that you practice these types of problems, you'll start to see some patterns that'll help you simplify them more quickly. And that's how you simplify radical expressions when you only have numeric values.